All right, recording and re-rolling. So we're last 10 minutes of class right now. We're going to go over the solution to this lab. Well, actually, two perspectives, so two sets of solutions. All right, so for the first one, remember you were just doing this. You were pulling with a constant force, and that was causing the block to move at constant velocity. The only way for that to happen is, well, there had to be a friction force that was exactly opposing your pulling force. Okay. Now you guys know, and this I meant to point this out too. Let me just here. This expression rearranged a little bit is right here on your AP formulas. So yes, it says force of friction, the absolute value of that. Oh, look at that, less than or equal to coefficient of friction times normal force. Why does it say less than or equal to? Because this actually fields two different kinds of friction, static and kinetic. Remember, like, what if you do this? What if you only apply a little bit of spring force? Give you guys, I know some of you guys are wrapping up your procedures while I'm filling this explanation here. Okay. Well, if you just apply a little bit of force and it doesn't actually break the friction, that's still static friction, isn't it? Right. But if you're pulling it with constant velocity, so it's moving constant velocity, right, that's kinetic friction, right? Well, the fact that two surfaces sliding past each other is kinetic friction, right? And then you can take that inequality, less than or equal to, and just say equals, right? And then if you rearrange it, you know, the little algebra switch through, you get this right here. So now we're back to equals. Now, if you're just focused on coefficient of kinetic friction, if that's your question, you could just treat that as an equals, right? Okay, so the ratio of these two forces, which you guys know is also the ratio of these two forces because of the equilibrium condition, right? The pulling force compared to the weight, right? So that's where we were going with this one. I had you guys graph pulling force versus weight. So that's F's pull in some number of newtons versus the weight in newtons here, right? But you guys know that that's also the same thing as saying friction force compared to the normal force, right? When that would be true. Okay. And here's a 0, 0 right here. Okay. What does your graph look like for this one? Yeah, exactly. You guys got a linear relationship. Okay. If you did not get that, then that's okay. Your data is your data. But suppose you were, coming up with, that's the ideal textbook solution, right? Okay. And if you had no measuring tools and you're just like answering a question like at some FRQ or something, right? You should have this as your mental model, right? Because it's the ideal textbook solution. Right. This equation down here, F pull, also force friction, if you just substitute that value, is equal to, you should have gotten coefficient of kinetic friction multiplied by the weight, which is represents the normal force. So if you did coefficient of friction times the weight, now, or coefficient of friction times the normal force, right, there you go, right? Okay. And mu represents, you could have said the coefficient of kinetic friction. I guess what might also be valid is the slope of the line. I mean, those are both true statements, right? And so there you go. If you said either one of those, okay. You guys good so far? All right. Now let's look at an AP style point system for this. This is a pretty straightforward lab, so I just have a 7-point system for this one. Okay. Yeah. All right. So you guys broke out your color pencils. Right, unless you did the other write-up. If you did the write-up for the tilt to death, then hang tight because I got one for that too. So let's just focus on this one now. Okay. So here's your question. What is the coefficient of kinetic friction between the two surfaces? Right. So specify the surfaces. Right. Like me, maybe it's like paper and paper. Right. Measuring tools. You only needed one measuring tool, and that was the spring scale. So go ahead and give yourself a point if you said use the spring scale. Okay. Again, this is just if you did the write-up in the first one. If you did the tilt to death, then hang tight because we'll do that one in here in a minute. Okay. All right, data gathering procedure. Remember how to measure what variables using what measuring tools. So step 1, choose several lab weights of different masses. I put in the detail, cover the lab weights in paper so that they have all the same surfaces. But again, if you just, as long as you control for the surfaces somehow, if you use all the same metal against all the same desk material or something. Okay. So give yourself a point just for describing the basic lab setup. Okay. Just very briefly, 1 or 2 sentences. Here's the basic setup. Okay. It's a find out horizontal surface. Okay. All right. Step 2, hang the lab weight using the spring scale. Record the weight in newtons. Okay. So the question, remember, the ultimate question is what is the coefficient of friction between the surfaces? Okay. All right. So we got the basic lab setup. Bing. We got hang the lab weight and record the weight in newtons. bing. You guys did newtons, not grams, right? If you have a number on your paper that says like 200, I bet that's grams, right? You did newtons. Using the spring scale in step 3, using the spring scale, pull the weight horizontally across the horizontal surface at constant velocity. Record the pulling force in newtons. So 1.4, use the spring scale there. Bing. Okay. A lot of little details that are important. You get those exactly right. You have to pull horizontally, because if you pull any other way, then the normal force wouldn't match the weight, right? So you have to pull horizontally. And you have to pull at constant velocity so that all the forces balance out and you have equilibrium, right? Okay, guys get it? Step 4, repeat the previous step 2 more times to record the average pulling force. Give yourself a point for saying multiple trials. That'll always be one of the points on the FRQ that you're experimental design that you're going to get in A. Okay, you're going to get an FRQ. It's going to be experimental design. You're going to have to do a write-up just like this. And one of the points will be you did multiple trials to reduce experimental error or to reduce random error. Right? Multiple trials. Right. Step 5, repeat steps 2 through 4 for each of the other lab weights. So you have some kind of independent variable, right? Got lab weights. All right, let's continue this procedure here. Graph pulling force versus hanging force. Alternatively, graph friction force versus normal force, since that's an identical graph, right? Give yourself a point for making that graph. And then the coefficient of kinetic friction is the slope of friction force versus normal force, the slope of this graph. So 1 point for a property of the graph that determines the answer, which is slope in this case. Okay. And then finally, conclusion. The coefficient of friction, u sub k, is some number. Maybe you got, here, I'll give you guys some reasonable options. Maybe you got like 0.1, maybe you got 0.15, maybe you got 0.2, maybe you got 0.27, maybe you got 0.3, 0.36. Okay, you got something between 0.1 and 0.4. Okay, do you guys all get somewhere there, but between 0.1 and 0.4? Okay, I know it's a big window, but you know, you guys had different surfaces, so depending on which surfaces you picked. Okay. Okay. Another way to couch that is the pulling force, hence friction force, should have been somewhere between 10 to 40% of the weight. Okay. Guys, back. Right. Now this other setup. Okay, so that was out of 7 points. So setup. Let me just pass. I got just enough time. Okay. Now I'm still doing coefficient of friction as the ratio of these two forces, but let me do a bunch of substitutions. Friction force, isn't that mg sine theta? And normal force, isn't that mg cosine theta? True, true. So wouldn't the coefficient of kinetic friction be mg sine theta over mg cosine theta? Is that true? You guys follow that? You guys see that substitution? Does the weight cancel? Hey, what is sine over cosine? Tangent. Ah, how many of you guys caught that? That taking the tangent of the angle would also give you coefficient of friction, right? Again, as long as it's well, just this very basic setup, slide down constant velocity. Is that true? Right. That's where we're going with this one. Right. Now, what you should have gotten, since we're short on time, I'll just cut straight to the answer. You should have just gotten a constant value, right? Just straight across. You know, right? If you didn't, that's fine, but that's the ideal answer. The tangent of the angle should have just been some number like 0.36 or something, which is the coefficient of friction. Right. So they're the same thing, right? Tangent of the angle is the coefficient of friction. All right, let's do the points for this real fast. So it's the same question. What's the coefficient of static friction? This time you only had to use the protractor. You could do the whole lab with just the protractor, nothing else. Okay, give yourself a point if you said that. Again, this is if you did the write-up for the second half. Okay. Choose several labs, different masses, cover them in some material so that the material is controlled for. Find a tiltable surface, 1 point for the setup. Place the lab weight on the tiltable surface. Use the protractor to determine the horizontal plane. Tilt the depth. I should have said here, so that the lab weight slides down at constant velocity. On this paper, I typed static friction, but let's adjust that for kinetic friction, which is B. It slides down at constant velocity. That'll let you determine kinetic friction, coefficient of kinetic friction. Step 3, repeat the previous step 2 more times and record the average pulling force. Give yourself a point for multiple trials. Right. Step 4, repeat previous steps for each of the lab weights. You have an independent variable. Right. Then find tangent of the angles and the coefficient of static friction, or coefficient of kinetic friction, I should say, is well, just the tangent of the angle is what it comes out to. Right. you could have put it on a graph, can't data versus lab mass, but it should have just been a flat line, just like I graphed for you guys, right? Which again represents the coefficient of kinetic friction. The coefficient of kinetic friction is some number. And is if you're using the same surfaces, they should got the numbers pretty close to each other, maybe like 0.3, 0.35 or something.
How many final points are there for the first question?
There were 7 points either way. 7 points either way. Score yourself on 7. Pop that in the grade tray. See you guys tomorrow.